Hello, good evening, everyone. Um, I believe we are all doing good, and I also believe you all can hear me. Please, if you can hear me, I would like it to type on the comment section. I can hear you. We're going to take like 2 minutes for that. Okay, can you hear me? Can you hear me? Yeah, good evening. Good evening, Marvelous. Okay, you all can hear me. That's okay, okay. That's nice. Welcome to today's class. I like the reaction I'm getting. I like the number of participants I'm seeing. There are a lot of persons turning up um for today's class. That's a very good one. We are already past. We are 8 minutes behind. I believe you all can see my screen. So before we proceed, I would like to know your name. I would like to know you. Please kindly introduce yourself in the chat box. Your name, if you're a member of APWEM, your chapter. If you are not a member, kindly indicate also. Um, if you're a student, you let us know your department also. So we are going to take that for 2 minutes. 2 minutes max. Yeah. So please just do a brief introduction. So I'm waiting for you guys for your introduction. Just few minutes. We are not going to take time. Okay. Okay. Yeah. Someone is saying APWEM is an association for women. Yes. I know. This program we are collaborating. One of our collaborators is APWEM. So, if you're a member of NUESA, please also indicate. Yeah, I'm seeing electrical engineer. Welcome, Elijah. Opara Samuel, welcome. There are a lot of persons here. Okay, yeah. You already know why you're here. We are having a 2 days class on Aspen Hysys, majorly for process engineering, how to use Aspen to carry out simulation in the oil and gas. You can use Hysys for a lot of simulation, not just the oil and gas. It's being used in petroleum, it's being used in petrochemical, it's being used in the pharmaceutical, catalytic cracking, reforming, and few other polymer, also polymeric simulations. So before we go into the business of today, I would like to introduce the company that is organizing this training. Um, this training is being organized by Royal Grand Engineering Training Limited, and the abbreviation is Rent Limited. Rent Limited is a talent development company or a workforce development company, depending on how you want to see it. Our major aim is to bridge the gap between the academic and the industry. We can say that there is a huge gap between what's being taught in the school or in the university and what's being required from us as engineers. So how do we transit successfully from being a fresh graduate, um, with no industry experience to someone who can comfortably handle um, what is being or comfortably, yeah, do some deliverables or carry out process engineering design um, or suit into the industry. So this is where we come in. As a training institute, we prepare um, we prepare young engineers for what is required in the industry. And your instructor for today is no other person than the MD of Rio Grande Engineering Trainings, Rent. And I'll be taking you guys on Aspen Hysys for these 2 days. So what actually brought how did rents come into play? I studied chemical engineering from the Federal University of Technology, Futo, Owerri. Um, when I finished the university, I know that if I'm to employ myself, I know I won't make that mistake of employing myself. And why was that? Because I know I just I just have that certificate as someone who has finished university. But man, I know that I can't do anything if someone picks me now, puts me into the oil and gas, or yeah, you study chemical engineering, come and do something here as a process engineer. I know I can't do anything. I know I don't know how to use the softwares. I know that I'm a liability to the industry. So when I left, before during my final year, I was like, companies are supposed to be coming to us as young engineers. Come and do MATLAB simulation. Come and do Hysys simulation. We want the design organizations. But I will look at myself and say, do I know how to use Hysys? No. Do I know how to use Excel as a chemical engineer? No. Do I know how to use this one? No. Do I know how to use Olga? So it became a burden, and this was what led um, to rent, because I wanted to make sure that what I faced, young engineers like me are not going to face it. So this is why I started Real Grand Engineering Trainings to bridge that gap, to make sure that young engineers and also, yeah, young engineers have the skills required to face the ever-changing industrial world. Joshua, so I don't know, can you all hear me? Okay, it's loud and clear. Yes, so we organize trainings with different organizations, APWEM, NSE, students like NUESA and all of that. So some of you joined from NUESA, some of you joined from APWEM, some of you joined from your department group. You all are welcome, and you all are welcome to Rear Grind Engineering trainings. And today is the day one for this training. So we are going to start with Aspen. Yeah, ASPEN, and I believe you all can hear my screen. See my screen right there. The the A- A- Aspen is an acronym for Advanced System for Process Engineering. It is based on a flow sheet simulation. Please, I would like you to note this. Aspen, so when you are hearing Aspen Hysys, it's basically a process engineering, advanced system for process engineering, and it is based on a flow sheet. So what is a flow sheet? A flow sheet is a simulation. A flow sheet simulation is a computer software that is used to quantitatively model a chemical processing plant, which in addition to the core reactor unit, please, I would like you to take note of this. It is used to quantitatively model a process, a chemical process plant. I'm going to underline that. In addition to the core reacting reactor units, also include pre and post-treatment steps. Thus, simulation of an entire chemical um, process starting from the raw material to the finished product. It is symbolically represented by different icons, where each icon stands for a unit. Where each icon stands for a unit operation, chemical process, input and output material stream, input and output energy stream, or input and output electric pneumatic signal. So for those of you who can't make comments in the chat box, I would like you to, to subscribe to the channel. So it's only active subscribers that can make comments. Okay, now we know what a flow sheet is. In a layman's definition, we could also say, in a layman's definition, what is a flow sheet? In a layman's definition, what is a flow sheet? Now, a flow sheet can simply be said that it is a simplified pictorial representation of processes. So your chemical plant or your process plant, whatever you are doing, be it fertilizer, production of ethanol, production of this, production of methane, production of fertilizer, production of anything. Now, that simplified pictorial representation of how your feedstock is being translated to the final product is basically a flow sheet. So for those of you that have seen some kind of pictorial diagram or an organizational chart, so in an organizational chart, you see the chain of command from the director to his his direct sub, and their other divisions. That's just basic example of a flow sheet. It is a diagrammatical process. It is a diagram that shows the operating units involved in a process and their interconnections. I think this definition I just gave now explains it more. It is a diagram that shows the operating units involved in a process and their interconnection. So when you start looking at, and this flow sheet leads us to what we call the BFD, which is your block flow diagram. From that, you move to the PFD, which is your process flow diagram. Then that you escalate to P and ID, which is your piping and instrumentation diagram. So we are going to be seeing a lot of diagrams in process engineering. I'm going to show you one now. Okay, just give me a minute uh, for one. Okay, you can see this also. This is a flow sheet. So we have lots of diagrams here. We can see the operation, the unit operation, and the interconnection. Okay, this was what I was looking for. So we said a flow sheet is simply a diagram, first of all, that shows the unit operation and the interconnections. So this is a process gas compressor, multiple stage process gas compressor, and it is in multiple stages. We can see the input here. This is the input here, and this is our output out, and this in. So for senior engineers that are on this call, I'm sorry for going back to primary school. So I want everyone to be carried along in this. So basically, that's what a flow sheet is. So for those of you that the word simulation, when we are talking about simulation, we are trying to mimic real world experience. So how will this plant work in reality? How will this plant work in reality? How will this plant behave in a real world scenario? How should this plant behave? So we are trying to mimic or imitate the real world process. Okay. For instance, you are running a simulation of a man. You're carrying out a simulation of a man running. You want to compare the speed of an average man with an average cheetah. You have to look at, okay, how fast can a cheetah run? You put those parameters, that parameter, the cheetah speed, average speed, you put it there. Put that for the cheetah. You also impute gravity because they're not going to be floating. Impute friction, this and every other factor so that you can mimic that. So basically, when you put all this together, a flow sheet simulation. So it's basically a diagrammatical process that shows the interconnection of these operating units in order to imitate the operation behavior of a real chemical plant or process, typically using a computer software. Yeah. So when you are saying flow sheet simulation, this is basically you are using a software that operates based on a diagrammatical process and um it's imitating the real world system. That's it. So I believe that that explanation is good enough. So before we go further, I would like to ask, what's the difference between a unit operation and a unit process? We are in a chemical engineering class. What's the difference between a unit operation and a unit process? I would like to get your opinions on the chat box. Was a unit operation? What's the unit operation? What's the unit process? What's the unit operation and a unit process? Okay, I'm waiting, I'm waiting, I'm waiting. No one has an answer to that. I was expecting lots of responses. Okay, well, we are going to come to that. So for those of you that are from electrical and other departments, you are participating in, well, in Aspen Hysys training, no knowledge is waste, but most of the persons that are going to benefit from this are people in petroleum and um, petrochemical process engineering, maybe operations manager, plant manager, and all of that. Aspen Hysys flow sheet simulation enables us to run the following. One, to conduct what if tests. So when we say what if, we are looking at in a scenario where this happens, how will this plant behave? So that's what if scenario is. So for instance, our PSV, process safety valve. What if there is fire incident and this process safety valve is installed on a separator? What if there is fire incident on that separator? How should this process safety valve um, respond? What should happen at this point in time? If there is overpressure, what if there is overpressure on this vessel? What should happen to the PSV? What if this happens? So what if there is flooding? So with Hysys, you can carry out a lot of what if. Remember, we are trying to mimic real world operations. How will this plant operate in reality? How will this plant operate in reality? So we want to see how we can carry out these scenarios and get um, and know how this plant is going to react, how this equipment is going to react, and all of that. So we also have design specification. So design specification is actually what you call your equipment sizing, or in some other scenario, we can call it plant configuration. So when we are saying carrying out plant configuration, we are simply saying, okay, your entire equipment, your pipes, how what standard are you using to size it? I don't know if that I'm trying to look for another word to use in place of sizing, because basically most of you here might not know what sizing is. So what sizing easiest way I can say it is how do you know that this pump needs to give out an output pressure of 5 bar? How do you know that this pump will need um, X amount of power? So that's the sizing. You the word sizing is being used, so you can check that out also. So you can also carry out debottlenecking and constricting parts. You could carry out sensitivity analysis. You could run optimization. And why do we optimize the plant? So why do we optimize the plants? Why are we even carrying out optimization? Remember, process engineering, we are um, converting raw materials to finished products. So we are converting raw materials to finished products. And in converting this, we need to make sure that what we are doing, we are getting um, the best out of it. So if we you carry out your separation process, get the purification, then at the end of the day, you are meant to get 90% copper from this process, but we are getting 60%. So how do we get our 90%? So it means our plants, something needs to be done about with regards to that. So with Aspen Hysys, we could run simulation in order to know what to do to optimize our process. So optimization is maybe um, we are getting more yield. Optimization can also mean that we we are getting more yield at low cost. Optimization can also mean that smaller feedstock can still give us the same product or yield as maybe we are using 1,000 kilogram as our feedstock. Somehow we use 800 kilogram and we got the same feedstock, same quantity of products, treated products. So our plant has been optimized. We are now using less energy. You get maybe we are using steam, and for this plant, our source of heat is much, our energy is much. Maybe we now say, okay, it's like oil can do this work, or some other thing, or we can use a waste product of from our process to power the entire plant. Basically, that's how this plant operates. Some of these gases are used um, as source of combustion to run this engine. This engine. So that's basically that for optimization. Um, so with Aspen Hysys process simulation, we can design better plants and increase profitability. If we optimize our plants and we know that we can we are now using lesser energy and we are getting the same result or more, definitely, definitely we are we are going to increase our profitability. If we optimize our plants and we are the only one in the market that is, for instance, let's assume that copper, which I used as our previous example, what we have in the market is 90% purity, and we have been able to increase ours to 95, or what is in the market is 95, and we have been able to optimize ours to purify ours to 99% purity. Indefinitely, we have something the market does not have. That is to increase our profitability. We can use it as our catch. Get 99% copper. And we're also designing better plans. Okay. As for acid process simulation, we can translate process into Aspen Hysys Not Plus process simulation model by performing the following skeletal but necessary step. So in order for you to carry out your simulation, mimic how your plant is going to run in real, like the real world, there are a few things you need to do. The first step is specify the chemical components in the process. And how do we do that? We can fetch these from the Aspen Hysys data bank. We are going to look at that. The next thing we need to do is to specify thermodynamic model. So I'm going to ask you guys, what is thermodynamic? Yeah. Or what is thermodynamic property? You are free to use Google, you are free to use, but I need comments. So when you're looking, one thing I noticed even when I was a student is in a class like this, everybody just tend to say, yes, I'm following, right on, right on. Meanwhile, there are some key things that people don't know. So when we say thermodynamic, what do we mean? What do we mean? When we say thermodynamic properties, what do we mean? Please, I need your response. So we need to specify the thermodynamic model to represent the physical property of the component and mixture in the process. These models are built into Aspen Hysys. So the next thing we need to do is to define the process flow sheet. Define the unit operations in the process. So remember, we are now in flow sheet. And I told, from our first definition, I told you that it's a step-by-step process, isn't it? And it's a diagram. So this, I asked you, what are unit operations? What are unit operations? And you guys gave it to me. So I think I need to fall back to that and see. Okay, someone says a unit operation is a single fundamental physical step in a chemical engineering unit. Okay, I love what Praise Obiora said. A unit operation are governed by physical laws, while a unit process is governed by chemical laws. Yes, I think Opara Orisa Emeka Opara gave me the best definition I need. And John Cook, a unit operation is a step that only involves a physical change, while unit process involves chemical change. This is basically what you need to know from this class. Please, if you have not known this thing, please know it. There are people that have failed interview because they don't know this. A unit operation are governed by physical laws, while unit process is governed by chemical laws. But Obara Orisa, Emeka Obara gave me the best. And John Cook. Unit um unit operation undergoes physical change. Unit process undergoes chemical change. Just know these two, and it's well with you. Just do what? Just know these two, and it's well with you. Yeah, so someone said thermodynamic properties are the physical properties of a system that can be used to describe its thermodynamic state. Yeah, that's very good. That's very good. I love this. So next person said thermodynamics deals with the process of heat, temperature, and energy transfer. That's also good. So I'm interested in this thermodynamic properties because this is something that we're going to be hearing constantly as we go on, as we continue with this class. Thermodynamic property, thermodynamic property. So when we say thermodynamic property, we are basically looking at the physical property of this system. And what are those? Temperature, pressure, flow rates, and all of that. Those are the physical properties. Boiling points, which is start to do with temperature. Yeah, temperature, pressure, flow rate, mass flow. These are things we are looking at. So we are saying that we need to define um, where did I? Okay, we need to specify the specific thermodynamic model that represents the physical what property of the component or mixture. Second thing, we need to define the process streams that flow into and out of the unit operations. Um, then we need to select the model. We need to label them. We need to specify the components, flow rates, thermodynamic conditions. And you can see, okay, temperature, pressure, composition. Yeah. Then specify the operating conditions of the unit operations, operation models, applications of process simulation. Please, if you have a question, I would like you to drop it in the comment section. Yeah, I also like you guys to like this session. Yeah, give us a thumbs up. Please make sure you are subscribed to this channel. A lot of you are unable to comment, are unable to drop your thoughts. Please comment so that you'll be able to engage like others in the comment section. Thank you very much for your understanding. Okay, let's continue. Application of process simulation. Process simulation is a tool for process and chemical engineers that can be used in execution of repetitive tasks or in activities of high complexity that must be solved in relatively short time. The various applications that process simulation has found are results of the necessity of one, making better use of energy resources. Remember from when I talked about optimization, I made mention of energy. Minimizing the operating costs, I also talked about that. Let's a scenario where we are using 1,000 kilogram of feedstock, and at the end of the day, we are now using 800, but getting the same output or finished product. And emission of waste stream that can be contaminated. Um, so some of your waste can also be recycled or used as energy. We talked about increasing yield and process efficiency. I've explained this a lot um, from from our previous slides. Um, improving the process controllability, propelling the teaching of process design. Okay, so this is basically part of what we are doing. Why are we using Hysys? Why is Hysys necessary? So that we can teach it the way I'm teaching you. The necessity of Hysys to teach young engineers how to use it. Okay, so these are extensions of Hysys, which basically we are not going to bore ourselves with. As well as Hysys modeling and process simulation procedure, which is basically something we talked about in two slides before this. Um, we have our setup. You need to impute your title, description, and purpose of the job. We also have units of measurements. We have SI or English components, set your components, chemical components you want to work with, properties, physical and thermodynamic what property methods. I told you we are going to come across this countless, countless number of times. So you need to, when you say, have you checked the thermodynamic property? I'm basically saying, have you checked pressure? Have you checked temperature? Have you checked components? Have you done that? Have you specified that? Thermodynamic model you use, does it match the thermodynamic property of that um, components you are using? Yeah, you want to use in simulation, in simulating. Okay, please just give me a minute. I need to take water. And the last one is choosing your block unit operation. Then specify your stream, you run your connection. So I'm going to pause here a bit and entertain a few questions. Someone is asking what is the difference between MATLAB and Aspen Plus. I think you can just ask, check it online, ask Google. MATLAB basically has to do with some kind of programming. It's like Python, or yeah, it runs with code. Aspen Plus and Aspen Hysys are basically almost the same thing. It's like Corel and Photoshop. For those of you that do graphic design. Yeah, somebody said you made mention of processes like copper production, so it is applicable in materials engineering. Don't really know what you guys do in material engineering, but um, the little I know, but for those that it depends on the aspect of material engineering you are looking at. The material engineering I know of is basically, we also, when you start working in the oil and gas, there are people that specialize in that. So when you are developing, let's say a special pipe or a special equipment, why are we using copper? Why are we using carbon steel instead of pure steel for this? That's where material engineering comes into play. So why are we choosing stainless steel or polished steel for this surface? That's where material engineering, to my best knowledge. And yes, material engineering also can be used. So if we are looking at, okay, we need this production of, okay, this process needs copper purity of 99.9. So how can we get that 99.9% purity? Yes. So in the production of materials itself, you can use that knowledge. You understand? So as a material scientist, how can you optimize this to get 99% of steel? This of this. Yeah. So you have a valid point there. Can you get this slide? No, it's not possible. This slide is not for general public consumption. Okay, I think we can take a step further. So the next thing we are going to look at now is I'm going to introduce you guys to the interface of Aspen Hysys. Then in our class tomorrow, we are going to do few simulations. Yeah, that's why we are here. Engineering is practical. Anything you are doing and there's no practice, something else. It's not engineering. It's NG theory. NG theory, not engineering. Engineering is practical. So I believe you all can see my Aspen Hysys screen. Yeah. This session is going to last for an hour. Tomorrow session, an hour also. So for those of you that have, you know someone that is in chemical engineering, that is in petroleum, please share the link so that they can attend tomorrow's session. Please share the link. Gas engineering, okay, and all of that. So we have chemical engineers, anyone that is a chemical engineer, you have process safety, oil and gas, petrochemical, gas engineering. So there are a lot of them. So please um, share the link so that uh, those who haven't joined can join. Those who haven't joined this class, so they don't miss tomorrow's class. Okay, I believe you all can see my screen. Yeah. So welcome to Aspen Hysys interface. This is the welcome screen. Here you can see our recent models and their dates. So for this, you can see this is December 24th, 2025. Same thing, 23rd, 21st, 21st. If you scroll down, um, you're going to see orders, 5th March, 5th, 16th October. So all your recent drawings are going to show here. Then from here, you can open an already saved drawing or you create a new drawing. So with, with what we have learned so far, how many of you would love to learn aspect? If you can see my screen, type on the comment section, I can see your screen. Someone said I can't see. If you can see my screen, please type, I can see your screen. Okay, there are a lot of persons that can see my screen. Okay, so this is it. Then from here, we have other tools. Um, let's look at refining crude or gas processing tutorial. Let's open one of them. So we are going to be doing, we carry out simulation similar to this, or we might simulate a session of this in our class tomorrow, maybe, probably. So, but this is, you're meant to click on any of those documents there. You have access to, yeah, then you have what is new. This, what is new, I'm using Aspen Hysys V11. So from here, you can access, you can check the updates that have been done in Aspen V11. If you are using V12, what's the difference between V11 and V12? That's what Aspen is basically telling you. So when you click on examples, there are other examples already existing in Aspen Hysys. So acid gas cleaning, there are a lot of acid gas cleaning. If you want to see how to develop acid gas, so there are lots of tutorials, examples there. So you can just open one and see how it's been done. So maybe you want to model something similar. It's loading. Okay, my Hysys just went off. So I'm going to open it again. So, but why Hysys, as when Hysys is coming up, I would love to use, I'd love to take some questions. Okay, someone said is Aspen Hysys and Aspen Plus the same thing? No, they are different. I said that Aspen Hysys and Aspen Plus can be, I'm just trying to give an example. Like chemic graph is like CorelDRAW and Photoshop. No, Photoshop can do a lot of manipulations CorelDRAW can do. So that's Photoshop can be likened as Aspen Plus. CorelDRAW can be likened to Aspen Hysys. But Aspen Hysys gives better results when we are looking at oil and gas simulation. But Aspen Plus basically is more advanced than Aspen Hysys. Aspen Hysys is more advanced than Aspen Plus. But sorry, Aspen Plus is more advanced than Aspen Hysys. But Aspen Hysys is used more in the oil and gas. So any oil and gas facility you are going into, they use Aspen Hysys more. Any company that is running detailed engineering design, any process engineering simulator is mostly using Aspen Hysys. But Aspen Plus is advanced. It has a lot of database. You can carry out rigorous simulation. You can carry out rigorous simulation with Hysys. Okay, please drop more questions. Okay, my Hysys is back. I'll share my screen. Okay, so we are going to create a new file just for illustration purpose. I'll hit on new. Just wait for Hysys to respond to us. Okay, so this is what you are going to see when you create um your drawing for the first time. So a lot of persons have asked questions like, how can I do this? How can I do that? How can I get the software? How can I download Aspen Hysys? Um, how do I do this? How do I do that? So what we are going to do is we are going to have a class, a more robust class, where we are going to use Hysys in practical. Um, we are going to do more practical scenarios. So we are going to have a paid class for those of you that will be interested. So in that paid class, we are going to make available the software, as well as the software, so that while we are teaching you, we are also going to uh, you're also going to learn from you and practice. Um, I believe I believe that's okay. Yeah. So one of the things you need is a software. Sorry, it's a laptop, which I asked. how many of you have a laptop? Uh, a lot of you indicated. So in the paid class, we are going to uh, we are going to do a lot of exercises, and we are going to teach you how to actually use Hysys as an engineer. When you right now you can start going for applying as an Hysys simulator or Hysys instructor. Start earning like 150, 200 while still in school. You can carry out a simulation, you charge 500 for it. What you are learning here, you can charge someone 500K for carrying out a simulation. Late last year, someone reached out to us from Ghana. He said his company uh, has been subletting jobs, has been subletting process simulation jobs to someone external, and it is his department. Guess how much they do pay those people that they are subletting it to 1.5 million to carry out simulation. So he said he's tired of subletting it to outsiders, that he wants to know how the software is so that when they are giving him reports, this opening Hysys for him, he knows what they are doing, or he should know. And he spent a good money learning everything about Hysys. Paid our 300K, but definitely most of you here are students, you are not going to pay up to that amount to learn this. So this is a skill that can earn you a good amount of money while you're a student. And most of you are going to say, oh, I don't have money. There's nobody that has money. Oh. The reason why you are in school is so that you can get a good degree and get a job. But the truth is, if you get a good degree, does not mean you are going to get a job. Go and ask any engineer. Get a good degree and get a good skill. You're going to get a job. I'm telling you. So this class was supposed to stay for an hour. So if you have learned something, I would just like you to. So if you have learned something from today's class, please, I would like to know, drop some tip, what you have learned. What you have learned, you know, yeah, so that we can end this class and continue tomorrow. Um, Please, like I said, share the group, share the registration link so that more people can join. And if there are specific softwares you would love us to organize classes on, I would also love you to indicate, can type the name of those software from the chat box. I would love to learn AutoCAD. I would love to learn this. I would love to learn maybe one skill. I love to learn cybersecurity. I love to learn data analysis. I would love. Please, I'm waiting for questions. Questions, benefits from today's class, so that we can end the class. We have done the necessary things for today. Okay, someone said I want to learn Aspen to make money. That's fair. Some other person said Hysys. Okay, that's good. So Emmanuel, the Hysys software. Yeah. So someone is asking, is it applicable to biochemical? I think I'm going to make that research. Okay. Thank you all for participating in today's class. It's I've spent an awesome time with you. Um, the criteria to know for learning maths lab. Basically, you need your laptop and the willingness to learn and have math lab installed. Thank you once again for participating in today's class. We are going to see tomorrow. In tomorrow's class, we are going to have the main the main practical session of Aspen Hysys. Yes, we are going to carry out lots of yeah. To see you all tomorrow and have a good night rest. Thank you. the main practical session of Aspen Hysys. Yes, I'm going to carry out lots of to see you all tomorrow and have a good night rest. Thank you. The main practical session of Aspen Hysys. Yes, I'm going to carry out lots of to see you all tomorrow and have a good night rest. Thank you. The main practical session of Aspen Hysys. Yes, I'm going to carry out lots of to see you all tomorrow and have a good night rest. Thank you. The main practical session of Aspen Hysys. Yes, I'm going to carry out lots of to see you all tomorrow and have a good night rest. Thank you. The main practical session of Aspen Hysys. Yes, I'm going to carry out lots of to see you all tomorrow and have